and that's Wes Lambert. Wes has been an instrumental member of the Velociraptor community for a while now. And you'll always see him, whether it's on the Discord channel or coming up with various artifacts, kind of on the fly. He's meant so much to the community. So we're always happy to have him, especially on a day like today, where he can drop some serious knowledge. So Wes, I'm going to go ahead and hand it over to you. Before that, let me just give you a little introduction. Wes Lambert has over 10 years of experience defending computer networks through the architecture and implementation of tooling to facilitate digital forensics, host and network-based security monitoring, security automation, threat detection, and more across financial, healthcare, and software verticals. While not at the computer, Wes enjoys Indian food, playing soccer, and spending time with his family. Wes, I enjoy all of those things. So we are like two peas in a pod there.
Awesome.
So take it away, my friend.
Yes, sir. Yes, sir. Let me get this slide sharing set up real quick. I guess I'll have to wait for you. There we go. Okay, let's see if I can just do screen two. Let's see what this does. I can get it situated. Share. All right, and let me go ahead and go full screen here. If I can get this thing out of the way. Come on now. And there we go. Slideshow full from the beginning. Okay, we good?
It's looking good to me.
All right, cool. All right, again, my name is Wes Lambert, and this is Clawing Your Way to Compliance with Velociraptor. As Carlos mentioned, I have a little over 10 years of experience just doing various things in enterprise security monitoring, host-based monitoring, security automation, threat detection, defer, a bunch in engineering, some in actual response and that kind of thing. But overall, I'm an avid open source contributor. I'd like to contribute a lot back to the community, especially the Velociraptor community. You can see a few projects here on the slide, the Velociraptor Docker image, and then some other integrations with Velociraptor and kind of getting into SOAR over there. I also put out the Artifacts of Autumn thread last year about some awesome artifacts that you can find on the Artifact Exchange. So if you haven't checked that out already, again, it's on X or Twitter. And then you'll also see some stuff there in the Artifact Exchange from me. So that's a little bit about myself, but I want to talk a little bit today about compliance. Okay, and I know some of you might think, it's boring, right? I mean, not always, right? I mean, it's kind of a necessary thing, right? A lot of us have to deal with compliance in the enterprise, whether it's for maintaining strategic partnerships, like, basically meeting business requirements so we can do business, or really just maintaining a more secure posture overall and being able to adhere to some kind of standard to do that or some kind of framework. And Velociraptor is really well known, as you guys might know, about its DFIR and its kind of threat detection or monitoring capabilities. But a lot of folks really don't think about it, at least, I haven't heard a lot of folks talk about it. I've heard a couple talk about it for compliance purposes. So that's why I wanted to put this talk together and work with Mike to see what we could do as far as seeing how we can highlight Velociraptor in that area. So first, I want to talk a little bit about compliance for, some folks might not be familiar with certain things. So I just want to go through a basic intro here. And the first thing that we'll talk about here is going to be HIPAA. Obviously, well, if you don't know, it deals with the protection of healthcare information, protected health information, personally identifiable information. So there's, a lot of, work around there just as far as, what we need to do to secure those systems. Additionally, whoops, went backwards there. Continuing from there, we have, let's see, PCI DSS, right? So we're talking about cardholder data, and we're talking about digital transactions and payments. And I'm just going to stop my video here just for bandwidth purposes. And then we also have, we'll continue. Sorry, it's getting a little slowness here. We'll just give it a second. GDPR, right? So we're dealing with like privacy of our data across social networks or platforms. in that manner, dealing with accountability of that data and all the laws that go along with that in the kind of European space, right? And then aside from GDPR, we have NIST. So a lot of you probably are familiar with NIST as far as protecting either federal contracting systems or federal information systems, or just in general, a lot of folks use it for their, their compliance purposes to have a model to work from whenever they're trying to secure their systems, right? So those are just a few of the frameworks and standards that you might see. Next, we'll talk about some benchmarks or some implementations of these, and just give it a second here. And sorry, it's getting a little slow here. Here we go. We'll talk about CIS first, and CIS, the Center for Information Security. So what this covers is 25 different product families plus, so different OS, different operating systems like Mac OS, Windows, Linux. And it applies really to those, PCI DSS, NIST, and those kind of frameworks. And it helps us to secure our systems and adhere to those frameworks by publishing a set of benchmarks that we can go off and read through and implement in our own environments. And another one is going to be STIG. It's going to be more tied towards government, right? Like DoD or DISA security requirements are really going to govern what's in the STIG. And it's like kind of, it's a lot stricter probably than the CIS benchmarks, a lot more involved there. There are a lot of tools for each of these that you can go through and compare your overall posture. But these are just two of the ones that I wanted to mention off the bat as far as benchmarks and implementations of those other frameworks or standards. Now, continuing from there, we also, want to dig a little bit into the CIS benchmarks themselves. So here's just an overview of the process there of how they actually come up with a CIS benchmark. It's really that community involvement and everybody agreeing on what the scope is and what the standards are. Everybody gets together, they discuss this, and then whenever they have a consensus, then they publish the CIS benchmark, and then we have that benchmark available to us for a particular Linux OS or a particular Windows OS, and then we can go off and leverage that. And from there, we have something like this benchmark right here for audit system integrity. And this benchmark right here, you can see we've got a few different things such as the title, right? What we're talking about. We've got the profile. Where does this thing apply? Is it for just general information systems? Is it for corporate networks? Is it for like military networks or really sensitive networks? We've got a description, right? Like what does it do? Or what's this all about? So this description in particular talks about some Windows event IDs that might be concerned with this particular setting or this this benchmark, and then some rationale, right? Like, why is this useful to do this? Why would we want to look at these events? Why would we want this control in place, right? And then we also have the impact as far as, if we're not looking at this, how could we be impacted? How could this negatively affect us? Okay, so overall, that's just an overview of the, the frameworks, the implementations, and CIS benchmarks. So we'll continue from there talking about compliance and how it might apply to Velociraptor. So, let's talk about compliance in a nutshell. So the first thing, that we do is read some docs, push a bunch of extremely technical controls to servers and workstations, right? We do that, we just do that immediately. We make a bunch of teams across the enterprise, across the organization, really, really mad, including our own team. We're mad at ourselves. Everyone's really stressed and everyone's really tired. The auditor checks a box, and then our enterprise is impenetrable, right? Like security is done, we all go home. Nothing left here, right? Right. This is how we implement compliance, right? No, not at all, not at all. So what we really want to focus on here, obviously compliance, as you might have heard, is not a one and done thing. It is a life cycle. And this is just an example of a life cycle here that I have. This is from some F5 documentation. This is not a definitive life cycle by any means. This is just an example of how you might orient compliance and continuous monitoring in your environment. So the first step being observe, right? Like taking an observation, looking at what telemetry we have, how what our network currently looks like, what is the configuration now, and then kind of going from there. Seeing what systems we have, classifying them. Maybe we have certain data levels that we need to classify particular systems for, like production systems, cardholder data systems, right? Things that involve digital transactions. And then we need to demonstrate our compliance with the particular standard or the framework, right? We need to show that we actually have this stuff in place, these security controls, and then we have to be able to maintain them, right? We need to be able to adjust them later on. We need to be able to continuously monitor and make sure that these things are happening. All right, and then continuing from there, I talked about continuous monitoring. I think one of the most overlooked things, and a lot of people try to go into a bunch of other really fancy things, but one of the most important things that you can do in your environment is maintain a comprehensive asset inventory. It's absolutely critical, right, as far as identifying rogue devices on the network. Jim Bob's server in finance, right? It's in some back closet. It's been processing transactions since who knows when. Nope, everybody forgot it was there, but it actually runs the business. So it's very important. This is like probably the most important step, maintaining the asset inventory, and then continually classifying and trying to understand the systems as you need to, right? As they come up and as things change within your organization, maybe your network structure changes. Comparing the previous state against the current state, right? I mean, we need to see the old versus new. Is it better now? Is it worse now? Are there new systems that aren't configured appropriately? And then addressing these deficiencies as they arise and accepting risk as necessary, right? Overall, we really want to move towards that more secure posture just by implementing all these steps. We just want to get better than we were the day before, right? Or at least maintain what we had before. And it's really why we want to implement that continuous monitoring. So, you know what? Let's make it happen, Captain. All right. But before we get started, we need to have a way to take those benchmarks and translate the recommendations from CIS to something that's usable by Velociraptor, right? So how do we do that? Well, we might be able to leverage a little help from our friends in the open source community. And this is where I'd like to introduce the Velociraptor audit project. This is something that I've been talking and working with Mike through. It's right here at velocidex/audit, but this right here, this project maintains a set of checks that are converted into VQL. These checks are tests from those CIS benchmarks. They are Boolean operations that result in a yes or no result. So we can figure out if, we're actually adhering to this check, if we're actually adhering to this benchmark standard, or this profile. And then the reports are right there within Velociraptor, right? So we can see that within the UI and be able to act on that and respond accordingly. And so what this does is it really facilitates that rapid kind of identification and comparison of all the endpoint configuration, right? The security configuration against the compliance benchmarks, and we're able to ascertain, what is the state of things right now. All right, so continuing from there, let's talk about how it works. Now, we'll introduce another open source platform you might have heard of. It's a host-based monitoring, and they've made some strides in the past as far as doing some other things with the data from the stack. But it was primarily used for host-based monitoring, but it does have a module called SCA, or Security Configuration Assessment. And what this does is it allows folks that leverage the platform to monitor for compliance against those particular standards and those benchmarks. And you can see the link here. There's just a blog article there. But again, it allows us to check for things like HIPAA compliance, PCI DSS, NIST 853, and lots of other frameworks. So, maybe we can leverage some help from our friends here at Wazoo. Let's dig a little deeper into how we can do that. Now, the SCA file uses a specific file for each OS. There's one for Mac OS. There's one for Linux, different flavors of Linux, different flavors of Windows. So there's lots of different ones that are used in comparison, or that kind of in correlation with the CIS benchmarks. And given the structure of the file, we can easily parse it. We can pull down the file and create our own vehicle-based checks, which is pretty cool. And I'll get into that in just a second. So we have a SCA YAML here. It's just a visual representation, a very brief one here. And we convert this to an intermediate YAML file. And then from here, that YAML file will be converted into VQL. So we have the streamlined process of generating kind of an intermediate form that we can manipulate as needed and review on a manual basis. If we need to implement any changes, then we can convert that into VQL. Now, continuing from there, this is what the SCA file looks like. Oops, a little too far there. So you can see right here, it just specifies the policy for Wazoo, the Win 10 Enterprise, so Windows 10 Enterprise. And then you can see some different information like the benchmark for the enterprise, right? And a description, some references. And then it has a bunch of different checks down here and the compliance information. And then if you were to scroll down further, you would see some values and some expected values that you might find for that check and what we're actually looking for. And we can see here in the intermediate YAML, this is used for humans to be able to parse this easily, to be able to modify it as necessary if needed before conversion into VQL. But we can see similar fields here. We can see the source here, the Win10 Enterprise SCA file, and then the artifact name that we're going to generate from that. And we can see some different things here like the export and some different checks. So this is where we actually implement the functionality. And we see some column expression, the where expression, the test that was actually used from SCA. And we see some other things like some other things that are used in the conversion process. So we can again modify these checks if we need to manually. If we don't want to include a check, we want to disable it, we can do that. We can verify the configuration overall and just make sure everything looks good. So again, set SCA file to the YAML file after it's been converted. This is the converted result, I'm sorry. And then from there, we can run this right if we wanted to generate that ourselves. So we would just run go run in the source directory of the audit project, and then it would generate this YAML file that we see here that can be converted or modified and converted into VQL. Now, continuing from there, we have the actual artifact itself that's generated. And what we can do is we can set a disabled value in that YAML file on the previous slide, and that will remove any checks from being converted over into this artifact. So if we have certain checks that we don't want to perform because of business requirements or other requirements, we can absolutely do that. We don't necessarily have to run every single check. And again, that YAML file is converted into the VQL file that we see here. And that is done by running from the source, the audit directory. We just run make auditor to build the auditor command. And then we can run auditor VQL, then the path to the SCA file, the intermediate file. And then we can throw that in our artifact definitions, or we can collect it on the fly. Lots of different ways we can do that there. And this is just a look at the embedded check here. So right here, this is the actual JSON. So what this is, it's base64 encoded gzipped content. So we had the JSON here, and it's gzipped and base64 and encoded inside of the artifact. And that allows us to really compress it, make it smaller, make it more portable, the actual tests, and we can leverage the native functionality within VQL to actually parse that and look at that further. So if we wanted to look at this in CyberChef, we can do this pretty easily just for a visual representation. We don't have to do this. We can do this all with VQL instead of Velociraptor. But you can see here that we've got the original base64 and we're decoding that. We're geo-unzipping that. And then we're beautifying that real quick just to make it pretty. But you can see the actual checks that are inside of there embedded inside of that data. So that's pretty cool, right? And now if we continue from there, just like to show you something really cool. GeoCities for the win, CyberChef's theme. If you haven't seen that and you're coding late at night and want to hurt yourself, have at it. So enjoy. But just wanted to showcase that real quick. And this, I think I mispasted this, but anyway, this right here, the extracted checks, we can see the command run on the endpoints. We can see the regex here that's used to determine the actual value, the expected value. And this expected value right here, so what's happening is we're running net exe accounts, and we're trying to get the length of the password history that's maintained. And the expected value is supposed to be greater than or equal than 24. And then the value right here, you can see it's a command, basically some VQL that returns the value that's actually returned from the command. And then we also have the multiple checks and a single test. You can see the 0 and the 1 here. And this let command match function right here, this just tells us how it actually matched. You can see the command and the regular expression. And then we'll go off and do some caching function there, which I'll get to in just a second. But that is the extracted check there. You can see the various tests that are going to be run, or the checks that are going to be run within the test. And then we have the command match right here. So many checks use similar commands. So one way to help with this is by using the cache function to cache the commands and improve performance. And you can see just a blob down here, the cache function, and you'll see that in the vehicle editor. But you can see here that it's very good for performance to be able to cache the commands, and then we can compare using regex and actually reuse some of the stuff as necessary. So that's pretty cool to have that available. And then additionally, what we can do here is when we're ready to collect the artifact, we can collect it via the CLI if we want to. And so what we have here is just a CLI representation of just running Velociraptor, specifying the path to the definitions, and running a manual collect with the YAML file. And then we can get those results immediately, or we can jump that out to a zip file if we want to. So that's a really easy way to go off and run that pretty quickly and easily. And then we have the collection via the web interface. So obviously, just like any other artifact, we have this in the web interface. We can go off and collect this in an ad hoc fashion. Oops. Or we can run a hunt and collect it across many hosts at once, which would be ideal. And then right here, I mentioned the checks. This is just an overview of the failed checks that we might see. So we can see that, in fact, this password history here was not set. It was not being enforced for the last 25 or more passwords. We can see that TCP/IP services, set to disabled or not installed. I don't know, right? So, but some of these are going to be obviously essential to operations for some folks. Some of them are not, which is why we can apply that disabled field or that disabled key in the checks, and then it will generate the checks that we want. So that makes it pretty easy, pretty efficient for us to go off and be able to reuse that. And then from there, we can see, we can compare. We see that we had 12 hosts that had enforced password history set, but then we only had 10 hosts that had this UPnP device host set to disabled. So it looks like actually for some hosts, we do have this, are passing, but we do then have 10 that are not passing. And then we can flesh those out later with just some additional VQL, or just by specifying our notebooks or results set to include those hosts that do need to be remediated from that point. Now, we also have an all tests view that we can look at. And what this means is that we can get a better determination of what checks, since there are multiple checks or can be multiple checks within a particular test, we can see why a test failed. If one check passed and one check failed, we might be able to see that, or see in a more granular nature, what happened if it passed, what the value was that was returned. Sometimes there's no value, but then you can see the expected value over here. So we know what's going on, we know what it's looking for, and we can go off and address that accordingly. Now we can also see the failed tests overall, and we can see again some more context. We can see the different command that would be run, the regular expression, the expected value, the title, and all that good stuff. And we can also see something that's very useful. Just at a high level, if we don't want to dig through each of these, we might want some context around these events. So this command right here, this command context, this actually is what helps us flesh out that context. And what it does is, from the title, it helps to provide some additional context around what is actually being looked for. Here, it was trying to match account active no on net user guest, right? And we can see maybe why it didn't match there. We can see what it was looking for originally. So again, it's really useful to be able to have that right there within the UI, quickly, easily able to sort through it and see. Again, that's providing that context, that command context function, and it tells us why did that test fail or pass. Okay, but you might be talking about, what about risk acceptance? I talked about some of those checks that you can disable from the intermediate YAML itself, but this right here, we can use through the artifact itself, and we can actually overrule checks during collection if we want to. So we can do that at runtime essentially. And then, if we didn't include something originally, or again, because of business or technical reasons, we can then overrule that check inside of Velociraptor in the UI when we perform our collection. And then also, obviously we can apply any comments as to why it was excluded if we want to add a note there, just to make it easier for other analysts or ourselves to remember why we put that in there. Because, we all know how it goes. Sometimes we don't throw any notes in there. So, but wait, there's more. Remediation can also be applied. So this is somewhat in a basic state, but, will be improved throughout as we get, through the project a bit more. And all we have to do here is check the remediate parameter within the artifact, and we can actually remediate the configuration. So if the service was supposed to be set to disabled, or the password enforcement was supposed to be set, we can actually do that on the endpoint itself. Okay, so it's pretty useful to be able to do that. However, it does come with caveats. Obviously, you want to be careful. You might want to have tested this beforehand on non-production systems to ensure it works as you would expect. But, assuming, you have tested and confirmed everything works as you expect, this can be very useful to be able to apply those standards, those benchmarks, and better adhere to those standards. Okay, so now that we've gotten through that, I want to just do a very brief demo here, and I'm just checking the time to make sure I'm good. So I'm going to take a second here. I'm going to share a different screen, and then we will go from there. All right.
You got plenty of time, Wes, so take your time.
Awesome. Thank you, sir. If I can type, I'm just trying to get something up real quick. Louise can't type. Okay. Let's get this. Share screen. Move this over. Share screen number 2. Yeah. And if you can kindly confirm whenever you see that.
Got it.
All right. Thanks, sir. All right. So what we have here is the Windows Audit CIS Win 10 Enterprise artifact here. And this is, obviously, we've added this in from our generation. And I just want to show you real quick, actually, if I can pull it up. So again, it's pretty easy. This is just the audit directory here. I've just pulled down the file, and I've run make run here. And then you can see the auditor command here. And then if I just do HR auditor. All right, and then you can run this here, and I'll just run it directly. So just run the auditor command here, and this is using that intermediate YAML that we've parsed initially. Whoops, let's do here. All right, and now you can see that it creates the artifact, and it's huge in here, so I'm not going to scroll all the way through that. I just want to show you real quick. It's pretty super fast, really easy to do from that perspective. And then I've just imported it here inside of the Velociraptor web interface. We can see here it was generated from the Wazoo SCA project. And we've got that overrule checks parameter here where we can overrule anything if we'd like. We've got the remediate parameter, or if we want to remediate it. That's awesome. And then we've got that command, that caching I talked about before, right? Where we're caching those similar commands, and then we're matching, and then we're building that context around the particular test and around the generation. And now if I were to go off and actually collect this, you would see here, because I did not want this to fail, I will show you some initial results here. All right, so this is the results of basically all these different clients here, these 12 different clients coming through and running this particular hunt. And now what we can see here, if we navigate back over to the notebook, is we can see an overview of the different results, the failed checks here. We can see that we've got the client ID, the FQDN here. We can see the different checks that failed here, including the enforced password history, rename administrator account. If we were to scroll down, we would see the failed tests that correspond with these checks. And we could see, even more information about, what was happening here. But what I want to dig into here is just show you the count real quick. So if I were to actually go in here and modify this, take just a second here. And if I were to do this a little slow on me, counts, let's count, title. All right. Now we can see here, I just want to do a quick group by just to show you guys just a quick number of each one of these. We see that we have 12 of these here where we've looked for that password history. It's set to 24 or more. You can see that pretty much all 12 hosts have the same results here. Now this one implies the password history here. So if we were to actually run the command, if I pull up the net.exe account command here, let's see. Pull that over here so you can see that. Nope, that's bad. Come on. A little bit more. All right, cool. All right, so if we were to run net.exe accounts, we would see that the minimum password age here is 0, right? Or I'm sorry, where's the password history? Length of password history maintained, none, right? If we were to go in to the local security policy, just on this local system, we could also see that the enforced password history setting here is set to 0 passwords remembered. So, maybe we want to modify that. Let's see if I can drag this over here. And if we wanted to make this more compliant, maybe we could just apply this. Okay, so yeah, man, I'm doing the compliance thing, right? All right, let's make this more compliant. All right, and then if I were to run my other hunt here, and come back and get the results, and we would see the results here, where we actually have the password history. Now we have only 11 hosts. And if we wanted to dig in and see which ones we could do that. And what I'm going to do here is just exclude anything where, let's see, password history, where title, let's see, or actually we can just include only the ones with password history. And then from here, count, I think, let's just do this. Count. All right, now what we'll see here is the clients that actually are not yet patched. So if we want to flesh those out and then move on to actually, go do that on those particular hosts, make sure the settings are applied there, we can go apply that remediate action. Or we can also see that, if we go back to the test, we'll recalculate this real quick. We can also dig more into the test for those particular hosts, but hopefully you can see pretty quickly that, it's pretty easy to, after the first hunt, seeing that we had 12 hosts and then doing on this one particular host, seeing that we've immediately applied that result, we've rerun the hunt or the client is re-enrolled in that. And then we can see that that has now registered as actually compliant for that particular check. And then we can go off and, if we need to look at any other failed tests or review that, we can do that. Or we can scroll down a little bit further and we can see all of the tests that were run and get some more context around the particular clients that it was run on and around the actual check that was being implemented there. And then we can also see some other stats here. If we actually remediated anything here, we can see any remediation actions here. And we can actually see any where the checks failed, right? So if we actually went up here, I think this might change. So we just recalculate this and the other, nope, not that one, this one. And so we actually see on this host, this was the host. We could obviously sort these if we wanted to. This was the host. And the reason these look like this are because I'm running the Velociraptor pool client command. So it allows us to spin up multiple clients or simulate multiple clients. And this is the parent one right here, the parent client, I guess. And we can see that it's not it did not fail on this test did not fail, or the check did not fail on this host. So this gives us more of a high level as far as what's failing on each particular host. And then we can also go off and create additional dashboards or create additional metrics, right? One additional thing might be to create a server monitoring alert for checks that fail. Once you're in a state where you're comfortable with that particular check, then or those particular tests and that benchmark, then you can go off and actually have alerting occur, and it comes somewhat as a detection or alerting phase, saying that this host is not necessarily compliant anymore. Something happened, or maybe some other host has joined the network and it's not a compliant host. So it allows us to perform that continuous monitoring and go off and reenact or even schedule those hunts and continuously apply that configuration as we need to. So as far as the demo, I mean, that's really all I had, considering, just showing how the compliance stuff actually works in the UI. But, if you do want to check out the repository, it is available here at velocidex/audit. And there's some great documentation here as far as modifying the checks and running the checks. So we can see the different things about the failed check source, the failed tests, and how we can modify that and make that better in the future. So let me actually flip back to the slides, because I do have those things real quick. But yeah, I did just want to show you that real quick. Current slide. Yep. All righty. Let's see if I can actually get my video back on now without it going crazy. All right. There we go. All right. So for the summary, let me get my head out of the way. There we go. All right. So this allows us now, this this project, this audit project allows us to perform ad hoc security configuration assessments now, right? We can go off and collect that data in an ad hoc fashion as we wish. If we want to do it manually, we can schedule these things to do it automatically, leveraging those CIS benchmarks and custom audit rules. And we can remediate those things. We can remediate the different items as we need to, as we see fit. Again, alerting if we want to perform that alerting through a server monitoring artifact or something similar, we can do that. And then really the next steps, I think, would be to add some additional checks here based on different operating systems, because right now there is just the Mac OS, the Linux, and the Windows in there. But I'd love to add additional checks for different operating systems and different standards, at least for the intermediate VQL or YAML that's available. Additionally, different sources, right? So different things other than just the SCA files. The project was written in a way that we can use not only SCA files, but it can be adapted to other types of sources as well. So that's something that's worth exploring there. And also providing additional metadata, different compliance information, right? If it's like related tags or labels, if it's related to PCI DSS or HIPAA or something like that, GDPR would be super useful to have, as well as other references. And again, I think I mentioned, obviously, alerting for failed checks. Once you get in a state where you feel comfortable with the configuration that you have in place, and then I think from there, there's a great potential for the project as far as helping folks leverage Velociraptor from not only a DFIR perspective, but from a compliance perspective as well. Whoa, go too far. Come on, Wes. All right. So leave this now for any questions. If you guys have any questions, you can also reach me at the real W Lambert on Twitter. And then I'm also on infosec.exchange. And then if you want to check out GitHub, that's there as well as the audit project. Thank you for listening, and Mike also for help with the project and everything else. So yeah, thanks, guys.
Thanks, Wes. I think there actually is a question in the Q&A if you want to tackle that one real quick.
Okay.
From Carlos. It's not me, the other Carlos.
Yeah, okay. In the case of the regex, is there any way to make them localization aware? Okay, between different language outputs. I don't think that's supported now. I would probably have to leave that to Mike to answer. But it might be possible in the future. But yeah, I don't think so right now. But But yeah.
Awesome. Yeah, if any other questions, please throw them in there. Otherwise, thank you very much, Wes.
Yes, sir. Thanks, guys.
And Wes, if you can just hand me back, there we go. Sharing permissions. All right, great. Okay. We have reached the last break of the afternoon. It is 2:25 now. Just for the sake of consistency, we'll reconvene back at 2:45, so we don't have to, change up the agenda at all.